Okay, and then question number 14 looks like this is it. We're going to use this data and we're going to find R. Now, I think last time I got rid of the data, but let me see if it's the same. Stat, enter. No, it's a different set of data. Okay, so let me clear this out. Some of the numbers look close, but they're different. Clear. There we go. Okay, so 3, 5, 11, 16, 19, and then 2, 3, 8, 9, 6. Okay. Double check. I think it looks good. So now let me show you this. If you don't go through the stat process, like if you don't calculate, it won't give you the R. So if I do quit, and let's say I just went to VARs, and I went to statistics, and then I go to equation, and then I go down here to R, and I hit enter, it won't do anything because you actually have to go through that process. So if you're going that method, make sure you go through the process. So just to save myself some time, I'm going to turn these diagnostics back on so it just gives it to me all at once. So go stat, calculate, number 8 for that equation, and then just enter on calculate, and then here's my R. So R is 0.77. So let me just give you a little bit of what this means. So you have a scatter plot, number of TV commercials X, and then number of car sales. So usually we do this, we want to try to predict data. This particular company has 3 commercials, they sold 2 cars. This one had 5 commercials, sold 3. 11 sold 8. 16 sold 9. 19 sold 6. So you notice a somewhat of a pattern. As the number of commercials go up, the car sales go up. But then something weird happens on this last one. Car sales went down. So all we're doing when we do this regression is we're trying to get an equation to try to find the optimum, the best number of commercials to use. Because obviously too many commercials is causing some problems. But we made a model, we have an equation. This R value, the correlation coefficient, tells you the strength of the relationship. So it tells you how strong a predictor of commercials is to predict the number of car sales. So right now it looks like a positive relationship. The more commercials, you sell more cars. Okay, you show fewer commercials, you sell fewer cars. However, it's not exact. It's not a perfect relationship. So what this R does, it says 77%, basically as a percentage, 77% of the variability of the difference in car sales is explained by commercials only. Now there's other factors like people putting ads in newspapers, or maybe you hear radio commercial, or maybe word of mouth. So there's other things that people do to sell cars. But just based on the one factor of commercials, it's a 77. No. 77 is the strength of the relationship. 59% of the variability, that's what this R squared is the difference in the car sales and commercials. Because you might have 2 different companies that can both show 11 commercials, and they might sell a different number of cars. So this R squared that we haven't used really is a statistical concept, but it's basically taking this number and squaring it, and you get this. So that's how much variability is explained by just the commercials. So about 60% is equating for commercials only when talking about car sales. But anyway, that's just to kind of give you a better understanding of what this is we're calculating and what it's for.